Hello, I'm Bat Manning, and I'm here to say Manning Math is the way to go.
Holy cow! Guest speakers! That's great! Okay, Algebra 3 kiddos, here's what we've got today. We've got modular math. So, modular math. Now, remember when I said to you a couple weeks ago that something like 6 plus 7 is equivalent to 1? Now that's true, but where is that true? Think about it. Look at your watch. That's right, we don't have watches anymore, do we? Okay, look up at the wall. Look at the clock up on the wall. The clock says 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? Well, think about this for a second. What if we started at 6 o'clock right here, and then we added 7 hours to it? 1, 2, 3, 4, 5, 6, 7. 6 plus 7 is equivalent to 1, but I left one part out, I must admit. It's equivalent to 1 in mod 12. So here's the deal about modular math. Modular math is math in a circular system, whereas the math that we're used to working with is an infinite system. It goes on forever in both directions, positive and negative. This is limited to here. And here's another thing I think you'll like about it. You'll notice there are no fractions. No fractions in modular math. The only answers we're allowed to get are numbers within the mod. So in this case, we can only get these numbers. Now, I do have to make one change from our clock to modular math, and that's that we never start at 1 and we never end at the mod. We always start at 0 and end at 1 less than the mod. So our mod 12 is actually the numbers 0 through 11. But we still get 6 plus 7 is equivalent to 1. Now notice I'm also saying equivalent. I'm not saying equals, because it's not equal to 1, it's equivalent to 1. So it's essentially the same idea, but it's the equal sign we use for modular math. Now, here's the other thing we can do. We can count it around like this, and we can change the mod. So I could say, what is something like 1? Let's make it a little bigger. Let's make it 4 plus 3. What is that equivalent to in mod 5? Now, in mod 5, we have to realize we're going to use the numbers 0 through 4. So let's go ahead and draw that. 0, 1, 2, 3, 4. There's your mod 5 from 0 to 4. Now, what we would do is we would start at the 4. And yes, you guessed it, we would add 3 to that. So 1, 2, 3. And there's our solution, 2 in mod 5. Well, we could draw this out, we could count around and do all of that, but I'll bet you there's an easier way. We'll get to that in a second. So addition, notice we're going clockwise around the clock. Clockwise, right? Addition, we're adding to it, we're going that way. What do you think subtraction is going to do? Yep, you guessed it, subtraction is going to go counterclockwise, the other direction. So let's try up here, let's try something like, oh gosh, I don't know, let's say 3 minus 6 in mod 12. Well, let's see, we start at the 3 right here. Then we're going to go backwards 6. Let's go 1, 2, 3, 4, 5, 6. And we end up at the 9. So our answer is 9 mod 12. Notice I'm saying what the mod is in the answer, not just giving a number. Down here, we could do the same thing. let's take something like 2 minus 4 in mod 5. 5 there. There we go. So we would start at the 2. Let's start here this time. And we're going to go backwards 4. So 1, 2, 3, 4. And notice we land on the 3. Okay. So of course we could draw this out. And of course Mr. Manning's going to point out that what if the numbers are bigger? What if we have 1,000 in our mod? What if we're talking 365 days of the year? What if we don't want to draw it all the way out? Is there an easier way? Of course there is. Here's what we're going to do. Let's change color. Let's go to some purple here. And let's see what 6 plus 7 would equal. Now 6 plus 7, we can do that. We know that. That's 6 plus 7. That's 13. But 13 is not in our mod. So we'd have to convert this answer to an answer that's within the mod. So what do you think we do? Here's what we do. We have to take all the 12s out. Every circle around comes out essentially. So here's what you can do. You can keep subtracting out the 12. But what if this number was really huge? What if we did a multiplication problem like, oh, I don't know, what if we did something like 10 times 11 and got 110? Well, subtracting 12 out of it, it's going to take a number of times. So the quicker way to do this is division. And it's actually the remainder. So think back to elementary school when we did division. Calculator decimal is not going to help us here. We need the remainder because that's our solution. So we're going to take 13 and we're going to divide it by 12. So I'm going to take 13, divide by 12. 12 goes into 13. How many times? Well, it goes in once. Yes, 1 times 12 is 12. And here it is. When we subtract, we get our remainder, R1. That's the same solution. This here, right there, that's the same solution. Okay, well, what do you think we do if we get a negative number? Well, 3 minus 6, that's actually equivalent to negative 3. Well, what we do is we subtract that from the mod. Take that away from the mod. So it's like this, but we're rarely going to get a negative. I'm not going to do this to you. That's more than one iteration around. So if we've got negative 3 here, take the mod 12, subtract the 3, and lo and behold, there's your 9 right there. Same answer. Does it work for a different mod? Of course it does. 4 plus 3, that's equal to 7. We're in mod 5, so 7 divided by 5, 5 goes into 7 once. 1 times 5 is 5. Here it is. The subtraction gives us, there's the 2. The remainder being 2. That's the same answer we had right there. What about with the negative? Same idea as up above there. 2 minus 4 is actually negative 2. Take the mod, 5 minus 2, and there it is. There's the 3 answer that we got right there. So, addition, clockwise, subtraction, counterclockwise. Go ahead and do the regular math, and then do division and get the remainder. That's the same answer that you get. Now, last thing we've got to get to, I believe, is multiplication. So, same idea. Multiplication, we just go ahead and multiply. So let's go ahead and try one. Let's try, oh gosh, let's try a different mod that's not even drawn up here. What if we did 3 times 7? What's that equivalent to in mod? Now realize our mod has to be larger than 7, right? So we could do mod 8 or above because we'd have in mod 8 the numbers 0 through 7. So let's go ahead and do that. Let's do mod 9 just to do something weird in mod 9. So what is 3 times 7? Well, 3 times 7, you guys know, is equal to 21. So now we're just going to convert it. So we're going to convert 21 into an answer in mod 9. So we take 21, divide it by the 9, and what do we get? 9 goes into 21. Let's see. Well, 3 times 9 is 27. That's too much. So 2 times 9 is 18. We subtract, and the difference there is 3. Remainder 3. There's our solution. The answer to 3 times 7 is equivalent to 3 mod 9. And there would be your solution for multiplication. So, the thing you're going to end up doing in the homework tonight, because yes, you will have the homework for this, you'll end up doing some adding and subtracting. I have a worksheet that's going to have 4 pages that I'm going to go ahead and attach. So you'll either want to download that and print it, or at least write it out on the paper so that you can do it there. It's got instruction right along with this, like this. And we're doing addition, subtraction, and multiplication. In the textbook reading, which adds to this idea, they're going to talk about the properties of equality that we've used before, and just our regular old properties. Do they apply for modular math? Think about the associative property, the commutative property, the identities, all of those guys. So they're going to have you read about that, and we'll talk about that during the conference time when we can all talk together. So I look forward to seeing you then, folks. Have a good day, and here's your joke for the day. What did Mars say to Saturn? What did Mars say to Saturn? Give me a ring sometime. Give me a ring. Ding-a-ling.